Hi to week. Welcome to week 2. We're going to be looking at a few of the areas that we have talked about in class and continuing to prepare you to come back to class for your test and your quiz, if we have a quiz. For the most part, it looks like a lot of you are doing the work in the classroom, and I appreciate that. Couple things to talk about in terms of the class itself. When you guys are emailing me, please a couple things to talk about today. Number one is email. When you're emailing me, please state the day or the class that you're in. It really helps me out. Make sure you're completing the tests and the discussion boards. There is a discussion board in Module 1, and I don't know if hardly anybody's done it yet. It's important that it gets done. And again, please contact me if you have any questions. This is a picture of the discussion board. Okay, this is in the module page. So, making sure that you understand that there is a due date. Okay, click on this. It will take you to the discussion board. And then download this document and answer the questions. It's pretty simple, just have to get it done. Let's get into a few things. When in this topic we're talking about the normal curve and the different types of curve. On the bottom here, these are the three most important ones. These two are also important, but these three are the most. You can see that in the normal curve. It's got a normal curve. It's called the bell shape, and all the scores are going to be centered around the middle of here, of the bell. The bell moves negatively and positively, which means if it's negatively, all the scores are going to be basically to the right. But the tail over here is to the left. As you can see, the tail over here is to the right, even though the everything else is to the opposite direction. So all the scores would be here. Okay. Unimodal means there's one is basically the same bell-shaped curve. Bimodal means there's more than one basically hump, or the scores are centered in two different areas. Of course, multimodal would mean that the scores are spread out between three separate areas. Skewness. This is a symmetry. Symmetry is the same word as shape. So when you hear the word skewness, you think of shape. It's the shape of something. When we're looking at the positive and negative skewed distributions, the scores basically fall under these areas. Okay? These are the different shapes. If we're talking about a normal curve, you will see it here. So the skewness, perfect normal distribution would be right in the middle, and it would be 0. Okay, you'd see it look like this. It's very, very rare. Looking at some different things of the skew. Remember we talked about the mean and the mode. Okay. When you have a positive skew, the mean is greater than the mode, and a negative skew means mean is greater than the mode, and a negative skew, the mean is less than the mode. Okay, and this can be done. You can look at this in the numbers. So let me give you an example. Negative skews. The reasons for it. The test could be easy. Testees performed well. Okay, meaning if I look at the negative skew, the mean itself, the mean is less than the mode. Okay, in the positive skew, the tests were too difficult, which means the scores, the mean score was higher than the mode, and either that or the tester's closer to 0. Standard deviation, denoted by an SD. These letters are always italicized. Okay. When looking at the standard deviation, how spread out the numbers are compared to the mean. So in the idea that I have a normal distribution, okay, and my mean is here, okay, and let's say my mean was 100. And let's say my standard deviation is -1. Along this line here, it's -1 standard deviation, -2, and -3. So basically all the scores, the majority of the scores, fall within 1 standard deviation from the mean. This is a visual picture of your data. Just as we looked at the histogram and all those other things, this basically is a histogram. So you'd run a histogram, draw the line, and then you have this. So standard deviation, how spread out the scores are. So along this line, which you'll see in a picture later, there's lines, and there's 1 standard deviation, 2 standard deviations, 3 standard deviations away. Same thing going the opposite way from the mean. So this, whatever line in the middle here, is the mean. Okay, here is the symbol for it. Okay, and then the formula is it is the square root of the variance. So let's ask, what is the variance? And that slide is not there. We will get to the variance in a minute. Kurtosis. Okay, kurtosis, where skewness is the shape. We're still looking at the shape of it, but we're really looking at how high the peak is in kurtosis. Okay, you can see that leptokurtic, and you just have to remember that all this portion of the word always stays the same. Lepto is high, meso looks more like the normal distribution, and platokurtic is underneath. So it goes up big for lepto, then it goes normal for meso, and then platokurtic goes underneath it. Okay, high and thin for lepto, normal in shape for the meso, and flat and spread out. Okay, I always think of a platypus when I'm here, meaning flat. And lepto sounds high, and meso sounds like the mesa, very flat land. The mean. The mean is one of the biggest things about the mean is we will be using this word all the way through the semester. So understanding what the mean is will help you in each of the tests that we're going to be running. Okay? The mean, to find the mean, this is what the mean letter is. We take all the numbers and add them up and divide them by the same number. So if I have 1, 2, 3, 4, 5, and 6, so what's that? 1, 3, 6, 10, 15, 21, 21, and then it would be by 6. 21 into 6 is approximately 3 point whatever. So that is your mean. Okay? It is the average. Okay? Not the middle, but it's the average. Okay? Median is the middle number. Okay? Just remember, middle number. And we won't talk about the median much more. It's just something you need to have in your arsenal. If you hear the word, then you'll understand it. We mostly we really look at the mean. And the mode is the number that appears the most often. So if I've got 1, 2, 3, 4, 5, 6, 7, 8, 9, the mode is 6. The range. The range is a pretty easy thing to talk about because it takes the top and the bottom number. That's what you're really looking at. And then how many numbers are in between. Basically, if we're talking about age, let's say the age of the class is 18, and that might be somebody in the class itself. And then you go all the way to 52. I won't turn 53 till next month. 52. The range is from 18 to 52 years. Okay? Getting back to the variance, I'm sorry about that. The variance is defined as the average squared differences from the mean. Okay? So, and then basically this is how you do it. But the variance is the average squared difference from the mean. So again, it's a formula that helps to understand the mean itself and the standard deviation, how the standard deviation works in that visual picture. Another thing that we really won't be talking much more about this semester. Z-scores. Okay. You can see here that when we talked about the standard deviation, okay, right here it says the standard deviation is a 3. So along that line with the bell curve, okay, it starts out with 0, which is basically the mean, okay, -1, -2, and -3. And it goes on to infinity. These are the tails. Okay? Over here you have 1, 2, and 3. Okay? Standardizing the scores in some ways in some things is easier, and sometimes it needs to be used in formulas. So in this case, this Z-score basically is the same as a standard deviation. It just changes the score. Now this can be also done because the data may not be in it may not have a great distribution. It can be skewed a little bit to the left or the right. So you standardize the scores, which creates the Z-score. And you'll see as we keep going that these numbers don't change at the bottom here. It's still 0, -1. You see that the numbers right here basically are the same as the standard deviation. So when the Z-scores are run, again, a lot of this stuff such as histograms and scatter plots and box plots and all the other things like this, and this visualization of the standard deviation is for you to see how the visual picture of your data is. Okay, you can create numbers and get answers, but the visual picture of how data is derived into whether it be columns or pods or something underneath them, something like a histogram to do the normal distribution, it goes to something that's called assumptions. And the biggest one across the board is assumption of normality. Okay, so if I have something that's skewed to the right or skewed to the left, and I believe it's actually normal, then your mean is so far away from where the center of here would be, okay, it's not a good representation. So what happens when, let's say everything is skewed this way? Okay, we have non-parametric tests, which are like, okay, you have it's like being a parent. You have these very, very strict rules, and then you have the backup rules that go with it. In case this rule doesn't work, we can take a little step back. Well, that's basically what this is. It takes away those assumptions. Now, assumptions is a different word than, like I'm assuming something. No. All assumptions are I'm assuming my data has these different criterias, which is something we will get into in another lecture. So this is where you need to be. Make sure you're studying this and you understand this and you've watched it, and you can watch it a couple times. And again, make sure that you're staying on task. We'll be back in the classroom soon. Check the emails that come through in terms of what your class date is and what day you're going to class. And other than that, if you have any questions, give me a call. And if not, have a wonderful week.